All right, so what I'm going to do is I need a second to transform my computer into a tablet here. And again, I can no longer see your name or the fact that you're online in my chat. So if you have a question, you're going to have to actually speak to me, okay? So here we go. We're just going to start. I'm just going to start writing, and I'm trying to write neat for you guys because I know it's sometimes hard to read, on a computer screen. So tell me if I need to fix something. And the first thing, we have some definitions. We have to get some definitions out of the way first so that we know what I'm talking about. And so the very first word that we're going to look at here is the word relation. And the definition is pretty straightforward. It is just a set of ordered pairs. And we know that a set of ordered pairs just means x comma y. That's what a relation is. It's literally just this. So any point that you have, maybe -1, 3, -10, 20, something like that, that's just a relation. No need to overcomplicate it. Now, the reason why we need to know what a relation is because there are special parts of the relation. There's this x value, and then there's also this y value. And these guys have special names, and we have to know what they are. And so the second vocabulary word is the word domain. And the domain is simple. The domain is just the set of all the x's. That's it. And then in parentheses, which this will come in handy later, we're going to say that also tells us how far left and right. And we're not going to need to know that until we look at a picture. So for the time being, all we're concerned with is that the domain is the set of all x's. So it's all of these guys up here. Any point you have, it's all the x values. That's it. That's the domain. Now, the next word is range. And the word range is simple. It's the set of all y values. And something that we'll need to know later, this will tell me how far up, whoops, oh, spelled up wrong. How far up and down. But for the time being, all we're concerned with is this. It's the set of all y's. So it's the second piece. Any y value is considered to be the range. So these are our first three definitions: relation, domain, range. Are there any questions on what any of these three words are saying? Okay. So I'll give you a second to make sure you have all this written down, and then I will clear this whiteboard and we will start looking at some examples now that we have these definitions out of the way. So before I erase these, any questions? Okay, here we go then. All right, so the first example that we're going to look at, so example 1, we're going to say B equals, and we're talking about a set, so we have some things. We have the point -4, 2, and the point 6, -1, and the point 0, 0, the point -4, 0, and the point pi squared. So here's a set of points, okay? And these are just, like, if I were to draw a graph, I could plot them over here somewhere. I don't know. They'd be on the graph somewhere, okay? We don't really care where. I don't care what it looks like. What I care about is this. Are you able to look at a list of points and tell me the domain? Easily. And then also, looking at that same exact point, tell me the range. Well, according to our notes from just the previous page, the domain is the x values and the range is the y values. And so when I look at this list of points, I have 1, 2, 3, 4, 5 points. Well, I have this x value and this x value and this x value and this x value and this x value. And so when I go to write my domain, I'm going to write it as a set. And I'm just going to write them in the order that they come. So the first one is -4, and then 6, and then 0. And hey, look, when I get to this -4, do you think I need to list that number twice?
No.
No, I don't. So I've already taken care of -4. It's already in there. And then the last one I have is pi. And there's my list of all the x values. And so these 4 pieces, that is my domain: -4, 6, 0, and pi. That's it. What are your thoughts on finding the domain?
Good.
That wasn't so bad. And so now I got to ask you, we have to find the range. Well, we know, according to our notes, that the range is just the set of all y values. And so again, I say, well, I put them in the order that they come to me. And so I have 2, -1, 0. But look, when I get here, I have a second 0. We already talked. We don't have to show that twice. So he's already been taken care of right there. No problem. And then lastly, I have pi squared. And so here's my domain, here's my range, and now I am finished. What are your thoughts on this particular problem?
Not hard.
Not
Nope.
hard.
Easy.
It's good.
Yeah, it's good. It's just maybe something that we've never seen before, but that doesn't mean bad. All right, can I move on to the next one?
Yeah.
Okay. So here we go. And now that one was easy. That was very straightforward, very easy. Now here's going to be a problem where we see a graph. Okay, so we're going to have some points here. Okay. And out of these points, I'm going to create a picture. This is going to be a rectangle. And so what we're going to do is we're going to look at this picture, and I need the domain and the range. Well, as previously mentioned on the last slide, the domain is just the x values, and the range is just the y values. And so what's going to have to happen is I'm going to look at this picture, and I'm going to ask myself, only looking at the x-axis, how far to the left does this shape go? Well, right here. It stops right here. What's the x value of that point?
2.
-2.
-2. Uh-oh, hold on, sorry. Oh no. Okay, hit a wrong button. -2. And since this dot is closed, that's where I'm going to use my bracket. All right, so I'm still looking at my x values, and I come over here and I say, okay, well, this is as far right as this picture goes. And so what is the x value of this point?
+1.
It's +1. And since it's a closed circle, I use a bracket. And so there's my domain. And so back on our very first page, when we started talking about definitions, we had said that the domain means how far left and right. That's what I've done here. I've said, how far left am I going? How far right am I going? Well, it's from -2 to 1, and now I'm finished. Now I have to do the same thing with the range. I have to say, okay, well, according to the range, according to the definition, I'm only looking at the y values, which tells me how far up and down. And so if I look, I want my smaller number to be first, and so I'm going to look down. What's the y value of this point? How far down does this thing go?
-3.
-3. And since it's a closed dot, I will use my bracket. And then I'll say, okay, well, what's the y value of this point? How far up does this thing go?
+3.
+3. Okay, done. There's my domain. There's my range. Finished. What are your thoughts on that particular problem? Any questions at all?
Pretty easy.
Yeah, pretty easy.
How do you,
Has anybody ever done this before?
Mm.
No.
No.
how
Okay,
do
so
you
it's
do
new.
that graph?
Pardon me?
How do you do the graph thing? Or
I-
like, where did you get your points from? Or was that already just pre-made?
That will be pre-made.
Okay.
So
that's
what'll
what I was
happen-
confused
yeah.
on.
You'll be looking at the black pre-made picture, and then you'll have to
Okay.
come up with this stuff. You have to say, oh, based on the picture, here's the domain, here's the range.
Okay, great. That's easy
Well,
then.
Will there ever be more points on there that have open circles so it like continues the numbers?
Yes, and I'm about to show you one like that, okay?
Okay.
All right, so here we go. Let's take a look at a new one. So same idea is you're going to be given a graph, and maybe, you know, it goes down to here this time. Here's an open circle, let's say, and it's going like this. And so I need to find my domain and also my range. And so again, the domain is going to be going how far left and right. And so if I look at this, it looks like it stops right here, and it looks like it stops right here. But does it actually stop right there?
No.
What do these arrows mean?
Infinity?
Okay, it does mean infinity. It also it means that this line's going to go up forever, but which direction is it also going? It's going left. Because what's happening as we're coming out this way, my graph is getting fatter as it goes upward. Okay, so we have to be careful and not let these little black arrows confuse us. So technically this graph is going all the way. Well, what do you think's happening over here? The same thing. And so what's happening is it's continuing. And so my domain, how far left have I gone? Well, I've gone to negative infinity. How far right have I gone? Well, I've gone to positive infinity. What's another way that I could write positive to negative infinity? How about all reals? So when you look at this picture, I need you to tell me, oh no. I need you to tell me, does me saying that the domain is all real numbers, does that make sense? Can you see how we're letting this thing go all the way to the left and all the way to the right? Are there any
Yeah.
questions on that?
No.
Okay. All right, so now we have to talk about the domain, which we know is the, oh goodness, which we know is just the y values. Come on. There we go. Sorry, guys. I'm still learning this. So here's the y-axis. And so again, we always want to start with our smallest number. Well, right here is as low as it goes. What is that value right there? What's that y value? How far down has that gone?
-4.
-4. Now, since this is an open circle, what kind of sign am I going to have to put right here?
Parentheses.
Yes. And now, so I look at this and I say, okay, from -4, and now I'm going up, 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 up. How far up am I actually going?
Positive infinity.
Positive infinity. Perfect. So there it is. There's my domain and there's my range. Now, whenever it comes to the domain, whenever it comes to this part up here, you can either write all reals or you can write the infinity. My personal preference is the all reals. However, if you put the infinity negative to positive, it's the same exact thing. So I'm going to use all reals a lot, but you could use this if you want. Now, as far as this question is, as far as this example goes, any problems at all on this one, guys?
No.
Okay, then I've got one more I want to show you just to make sure, and then we'll move on to the next topic. So let's say we have a graph that looks like this, and the picture on it, let's say, is just some random line that looks like this. And so, of course, the same thing, I need the domain and I need the range. And so when I look at this thing, these little arrows, we have to be cautious. These little arrows, they tell me that it continues forever. So even though I can't see it, this line is still going. And even though I can't see it, this line is still going. Well, how far, when we talk about the domain, how far left is this line actually going? If it's going on down here forever, which direction is it headed?
Negative infinity.
Negative infinity. And if this line is still continuing forever, which direction is it headed?
Positive infinity.
Positive infinity. And so what my goal for you guys is to be able to take a look at a problem, and without having to do a bunch of work, just give me the answer. That's my goal for you. And so hopefully you can just look at this picture and say, oh, the domain is all reals, because I know that that line's never stopping. That's the goal. Now, as far as the range goes, we're talking about the y values. We want to know how far up and down this thing goes. Well, again, according to these arrows, if it's continually going like this, how far down is it going?
Negative infinity.
Negative infinity. And how far up is this thing going?
Positive infinity.
Yeah. And so for this particular example, the domain and the range are both all reals. Now, my goal is for you to be able to look at this purple line and understand that. So what are your thoughts? Any questions, any problems on this particular example?
No.
No.
Okay, so that's pretty much domain and range in a nutshell. Okay, so we can't overthink it. You guys told me, hey, that's not so bad. Well, let's make sure we keep that attitude, okay? Now, the next topic on this, in this section rather, is what a function is. Okay, you may have heard us use the word function. Maybe you read about it. I don't know. But let me give you the definition. And then what we'll do is we'll look at pictures, okay? So in words, a function is a relation in which every element of the domain, which we know is the x values, is paired with exactly one element of the range. And we know that the range are the y's. And then to sum this up, to put it a little more plainly, we have to make sure we understand what this means is that no two ordered pair, or no two points, let's do it like that. No 2 points can have the same x value. That's what we need to know. No 2 points can have the same x value. That is the main takeaway from what a function is. So it's a relation in which every element of the domain, so every x value, is paired with exactly one element of the range, so exactly one y value. And what that means is none of the points on my graph can have the same x value. Now, I know that might not be extremely clear yet because, you know, a picture always helps. But for the time being, not on what this means, but just on what this says, is there anybody that has a question before we look at pictures? Because I think pictures are what's really going to bring this home. So any questions on this before we move on and draw a picture?
Not yet.
No.
Not yet. Okay, do I need a few more seconds to write?
I'm good.
Good.
Okay, I'm gonna go ahead and go then. If you need to chime in, you gotta tell me. All right, so we're gonna take a look at two pictures. The first one will look like this. And so we'll have a point here and a point here. This will be -3, this will be +3, and then we'll have a picture that comes through it like this. Okay. Now, this U-shape is called a parabola. We're going to talk more about this tomorrow. But basically what happens is you can see clearly that this is the point -3, 0. And this is the point +3, 0. Well, maybe if I chose this particular point, maybe he's -2, -2. And if I chose this point, he's +2, -2. And what you're going to start to notice is that this x value and this x value, even though they have the same y values, the x values are different. And this guy and this guy, even though they have the same y values, the x values are different. So according to our notes, none of the points on this particular graph can have the same x values. And you're going to see that even though they're close, they're opposites of each other. And so if I were to choose this point, whatever it may be, and I choose the point directly across from it, the x values will be different. If I chose this point, whatever it may be, the one exactly opposite from it, the x values will be different. So this particular little guy right here, this is a function. Now, on the other hand, let's say I had a picture that looked like this. So here's my graph. And let's say that it comes down like this and it doubles back and it goes like that, something like that. And so the problem here is that clearly you can see this value and this value and this point and this point, they all have the point 0 comma something. So this is the point, let's say probably 0 comma 3, let's call it. And then maybe this is 0 comma 1, and maybe this is 0 -1, and maybe this is 0 -5. Well, the problem is every single one of these points that we listed has the same x value, which happens to be 0. And according to the previous page, all the x values have to be different. So this 0 and this 0 and this, they're all the same number. And so over here on this side, this guy is not a function. So my goal for this, with this example, is for you to be able to look at a picture of a graph, no matter what it looks like, and tell me, is it a function or is it not a function? And so do you think, based on these two examples, that you could do that?
Yeah.
Yeah.
Yeah, I think so.
Yes.
Now let's pretend for just a second that you're like, man, I don't know if I could do that or not. Well, here's what's going to help you. There's something out there, which is pretty cool, that is called, and maybe you've read about this if you look through the notes previously, it's called the vertical line test. Anybody hear about that?
Yeah.
Pretty cool. All right, the vertical line test tells me the graph that we're looking at, so our picture, the graph is a function. Function if and only if no vertical line passes through the graph more than once. Graph more than once. That's what the vertical line tells me. Or excuse me, the vertical line test. No vertical line can pass through the graph more than once. And so what's going to happen once you guys have this written down, we're going to look at a few more examples of just pictures. We're not going to have to do a ton of work. We're just going to be able to look and say, oh, yes, it is, or oh, no, it's not, based on the vertical line test. So any questions about what the vertical line test tells me? Now I'm about to show you, but any questions on what this says right now?
Not yet.
Okay. So we're going to look at 3 more examples, and I'll be able to squeeze them on the same page so we can look at them side by side. And we're going to decide without having to do a lot of work if it's a function or not based on the vertical line test. So here's one. And so this one's going to have a dot here, maybe a dot over here, maybe a dot over here somewhere. But then we're going to have this dot and this dot. And so what we're going to have to do, and we don't want to have to do a ton of work, is we're going to look at this and we're going to say, well, is this a function? Does it pass the vertical line test? Meaning, if I were to draw any vertical line I felt like drawing, does it only pass through my graph once? Well, if I draw the vertical line here, yeah, it only passes through this point, so that's good. If I draw the vertical line here, yeah, it only passes once. If I draw it here, yeah, but what happens when I draw it over here? How many times does it pass through that graph?
Twice.
Twice. And so this guy right here, not a function. Now, what's going to happen in Hawks, they're going to show you a picture and you're going to say yes or no. If you say yes, you're fine, you're done. But if you say no, it's not a function, they're going to say, all right, give me 2 points that prove it. Because otherwise you might not be right. And so what's going to happen is let me get rid of some of these vertical lines so we can see where does the vertical line go through the 2 points? Well, that's happening over here, right here, with these 2 little guys. And so what's going to happen is these are the 2 points you're going to have to use as proof. And so we're just kind of rough guessing this. Maybe that's the point -3, 0 and the point -3, 2, let's say. And so what's going to happen is you're going to have to type these points in. And then Hawks is going to say, okay, now we're going to move on. But when they ask you for 2 points as proof, you need to find the 2 points that the line actually goes through. Don't pick this point and this point. They don't share. No line goes through those 2. Pick the ones that have the line going through it. All right, so there's one example of a picture that you're trying to decide if it's a function or not. Now, maybe we have one that looks like this. And so our line comes up like this. And my question to you is, hey, is this graph a function, yes or no?
Yes.
Yes. And so you're going to find a vertical line. Oh, hey, look, only crosses once, only once, only once, only once. So it doesn't matter which vertical line you pick. This is a function. Yes. And like I said, when you say yes, you do not have to prove it. You just click yes and you're done. All right, last one. Here's a picture. Let's say it looks like this. And so again, my question is, oh, Sparky's barking. My question is this a function, yes or no?
No.
No. And so how do I know that? Well, if I draw a line right here, look, it hits it 3 times. If I draw a line right here, oh, hey, look, it hits it 3 times. And so what has to happen is we would have to say, well, this point, whatever it might be, and this point, whatever it might be, and this point. And so here you would have 3 points as proof. And all you would have to do is type them out. I don't want to do that because there's no numbers, and this one was easier to see. But this answer is no, not a function. It does not pass the vertical line test. It's not a function. Now I'm done. Now,
Are we going to have to list every proof?
No, the only time you're going to have to give me proof is if your answer is no. And if it's yes, then you're good to go. You just move on. And if it's no, even if I think you're only going to have to do 2. But in this one, you could do 3. But I'm positive that Hawks is only going to ask you to give 2 points for proof. And so you could
Okay.
do this point and this point. And then you just type them in, and then you hit submit, and then you're good to go.
How do we write this down for Hawks notes?
You mean the ones that I put in Blackboard?
Like when we do Hawks on this, what would we write down on our separate piece of paper?
Oh, okay. So what you could do is you could write, hold on, let me just, so let's say you're doing number 1, and the question is this, and guys, whoever has the TV on, can you mute yourself for me, please? Let's say that this is the example, and and so over here's your paper. You would put number 1. You would put, yes, it's a function. Fine. And if number 2, if the answer was no, you would put number 2, no, and then let's say you list this point and this point, and then you have your points, and that would be it. It's not a ton of work because it is a lot of graphic stuff, but you could just give me yes, no, maybe, whatever the question might be. Okay?
Okay, just wanted to make sure.
Absolutely. Okay. Anything else before we move on to the next topic here? That is whether it's a function, yes or no. Any issues with that?
Good with those.
All right, now the next topic, we've been saying function, but we have to talk about what a function looks like algebraically, because it's not always going to be on a graph. And so the next thing that we're going to talk about is what's called function notation. And basically what's about to happen is we're about to say bye-bye to equations. We're not going to say that word equation a lot. We're going to start calling them functions. And so here's how we're going to get to that point. We're going to be given an equation. We're going to solve the equation for the letter y. We know how to do that because that's slope-intercept. We've been doing that. Once we get the y by itself, we are going to replace y with this. Does anybody know how to say this?
F of x.
Yeah. And so I'm just going to put here that this is read f of x, in case anyone's not sure. And then we're done. We're going to replace y with f of x, and then bam, we have a function. That's it. So a really, really quick, dirty, easy example is if I gave you y equals 2x minus 3, let's say, this as it is an equation because we have y equals. Because of this, this is an equation. Well, I don't want an equation. I want a function. In order for me to go from an equation to a function, my y equals has to go away. And so solve the equation for y. Well, technically that's already been done. Replace y with f of x. Okay, I can do that. So instead of writing y equals, I'm going to write f of x equals. And then this stuff over here, 2x minus 3, doesn't change at all. And bam, just like that, now I have a function. And that's it. So going from an equation to a function is a piece of cake. So what are your thoughts on just this one? All I did was take away the y and replace it with f of x, and now I have a function. Any questions with what we're about to do? Because that was an easy example. That was too easy. We got to kick it up a notch.
I feel like I know what's coming.
I bet you probably do. All right, so let's do one and let's see if that's what you thought was about to happen, okay? So what if I have 7x plus 3 equals 2y minus 1? And I need you to turn this into a function.
Solve for y.
Okay, so step 1, according to our notes, is solve for y. Well, we've been doing that for weeks now. And so how do you want to start out by solving for y? Let's add 1 to both sides. And so I'll get 7x plus 4 equals 2y. Okay, well, we're almost there. Y's still right here, so what do you want to do next? How about we divide everything by 2? Now, I'm going to pull a fast one on you. I'm going to divide, but I'm also going to put my y equals first. So I've taken care of this, and now I'm going to have 7 halves x plus 2. And here is my equation, which is great. This is the equation. But I don't want an equation. I want a function. And so once I solve for y, the last thing I need to do is what? Take y and replace it with f of x. And so just like that, I've gone from an equation to a function, and now I'm totally done. That's it. And this kind of looks like it's negative, but it shouldn't be. All right, what are your thoughts? We started out with some weird looking equation over here. We solve for y down here. We replaced y with f of x, and now we're finished.
Are we always going to replace it with f of x?
Yes, we are.
I didn't know if there would be another variable or something that we could plug in.
So eventually what's going to happen is we're going to see some problems that look like this. G of x equals blah, blah, blah. Maybe we have h of x equals blah, blah, blah. Eventually these x's probably in about 5 minutes, they're going to turn into numbers, but that's going to make me do something else. So as far as we're concerned right now, all we're doing is just going from the equation that we've been given to this form. Okay, but you're right, Sarah. We're going to have more things to happen. It's just not happening yet. Okay.
Okay.
All right, any other questions or problems right here on this one? Because I got one more that I want to do just to make sure.
No.
All right, so last one, and then we'll move on to the next topic. What if I have y minus 5 equals x squared? And I say, hey, I need you to turn this into a function. Well, what are you going to do?
Plus 5.
Okay, so that'll give me y equals x squared plus 5. Okay, this was another pretty easy one. Now what's going to have to happen?
I want to say multiply it all by 2 to
Oh,
get rid of the square.
no, let's back up for 1 second. This is okay. We're
Oh,
not gonna have x squared.
okay.
That's no big deal.
Just replace y with f of x.
Yeah, I'm going to replace this y with f of x. And my function here is going to be f of x equals x squared plus 5. And that's it. Now, I think Taylor, is who said that, right?
Mm-hmm.
I'm trying to remember everyone's voice. It's been so long. So I think probably what you were thinking is maybe, and I don't know, but maybe you in your mind, you saw something that looked like this. I don't know. Okay, if that were the case, we would have to get rid of this square. But down here, since this is just one teeny tiny little guy, he's fine. So this answer that we have is totally and completely acceptable. And so we're totally done. And so
Okay.
what do you guys think? We're taking an equation, we're solving it for y, we're replacing y with f of x, and we're saying, hey, guess what? I'm done.
Good.
That's not
Good.
bad, right? That's not too awful bad. Okay, now the next thing we have to do, the whole reason why we're doing that is so that we can evaluate. Because really what a function is, believe it or not, is just a line on a graph. That's all it is. So what we are going to do is we are going to evaluate f of x with actual numbers. And so what's going to happen is we're going to be given a function. So maybe I say, let's say if f of x equals 3 over x plus 2. So this is the function I'm giving you, All right, I'm giving it to you. You don't have to work for it. I'm giving it to you. Now I'm saying if that's true, then I want you to find f of -3. So I give you a function, I'm giving you a value. Well, the first thing you're going to notice is that this x has turned into a -3. And so what do you think is going to have to happen with this -3?
Plug it in for the x.
Exactly. So I'm going to come back over here, and everywhere I see an x, I'm going to replace it with this -3. So having said that, I'm going to have f of -3 equals 3 over, instead of me writing this x, now it's a -3. This +2 hasn't changed. And so now my whole goal here is to evaluate. I want this to give me a number. And so I will say, all right, what is 3 divided by -3?
-1.
And then what's -1 plus 2? It's just 1.
Yeah.
And so what's going to happen is over here is my answer. I'm going to say, oh, well, f of -3 is just 1. This is my answer. Now, here's the cool thing about function notation. The reason that I want us to write it like this is because what happened was we did have an x. We replaced that x with a -3. So I can write this as a point, -3. I took that x value. I put it into my function. I did some work. I got this value. Guess what? This is my y value. And so what's happened is from the function that I was given and from the idea that I can plug values in, I now have a point. This is an actual point. I could plot this point on a graph. I could do this over and over and over as many times as I want, and eventually I would come up with some line. I don't know if that's not what that looks like, but it looks like something. And so that's pretty neat, because what this function notation allows me to do is it allows me to graph a function pretty quickly without having to do a ton of work. So this is my actual answer that I would have to type into Hawks. This is just a byproduct. I have a point. What are your thoughts on this? You were given an equation, given a function, you were given a value, you plugged it in, you did some, evaluating, you got a value out, and you said, hey, look, here's my answer. And because of that, hey, look, here's a point. What do you think
Pretty
about it?
straightforward.
Yeah, I mean, it's just pretty straightforward. It's just different. You've probably never done this before, so you're probably a little hesitant. But this wasn't difficult. All right, let's try a couple more just to make sure this makes sense. So the same thing's going to happen. I'm going to give you an equation. I'm going to say, notice now I'm using g of x. That's okay. This can be any letter. It doesn't matter. Okay, so if g of x equals -4x plus 1, I want you to find g of the number 2. Well, the same exact thing has to happen. I'm going to take this 2, and everywhere I see an x, I'm going to pop the 2 in instead. And so that will give me g of 2 equals -4. Instead of me writing x, I write my 2 and then plus 1. Well, what is -4 times 2? -8. Don't forget this little plus 1. He hasn't changed. And so I'm going to get a -7. And so my answer is going to be g of 2 equals -7. And so the point that this is also going to allow me to see, what was the x value that I put in? A +2. What was the y value that I got out? A -7. And so I'm really getting two answers here. I'm getting the actual evaluation, and then I'm getting a byproduct, which happens to be a point. And now I'm done. Now, when you're doing Hawks, this is the one that you're going to type in. You're going to type in this value of a -7. What are your thoughts on this one? Same exact thing. You were given a function, you were given a value, you plug it in, you say, oh, here's my answer. Done.
Good.
Any questions, any problems on this one?
Easy.
Easy. Okay, let's do one more. Now, sometimes, okay, the value that I'm going to give you, this little guy right here, it's not always a nice, neat whole number. And so we have to talk about what's going to happen so that when you see that, you're like, oh, that's no big deal. So I'm going to tell you that h of x is going to equal x squared plus 4. And I'm going to ask you to find h of x plus 1. Now, the first thing that I'm sure you've noticed is this is no longer just one single number. Okay, it has two pieces. And so this little guy, you've heard me say this word, this is a quantity. Oh my goodness. Okay, I'm not going to write it. It's a quantity. So we have to treat it just a little bit differently. We're still going to do the same thing. Everywhere we see an x here and here, we're going to replace it with this. And so when I write it all out, it's going to look like this. It's going to say h of x plus 1 equals, and instead of me just writing x squared, I have to have my parentheses. There's my x plus 1. That whole thing is still squared. And then we can't forget about my plus 4. And so all I've done so far is anywhere I've seen just an x, I've replaced it with the quantity x plus 1. Any questions on what I've done so far? All right, now,
If we
oh, go ahead.
if we skipped the writing it with the square and just wrote two beside each other, is that okay?
Yes, because that's what's coming next, okay? So because of this little square, and because this is a quantity, I know that I actually have to multiply this. I actually have to square it out. Please, please, I'm begging you, don't forget that little constant here. What's the method I have to use when I have two pieces side by side?
Well,
Yes. So I'm going to FOIL this. So I'm going to get x squared plus x plus another x plus 1. And then again, I can't forget this little guy. So plus 4. Now I want to combine my like terms if I can. I only have one term with an x squared. Hey, look, two x's, so plus 2x. And hey, look, two whole numbers, so plus 5. And that's it. I cannot simplify this any further. So what I'm going to do then is I'm going to come over here, get rid of this so you have space. And I'm going to say that h of x plus 1 equals x squared plus 2x plus 5. And this is going to be my final answer. Now, on the last two problems, I was able to give you a point. Well, I can't do that this time because what did I put in? I didn't put an x value in. I put a quantity in. And what did I get out? Certainly not a y value, but a second quantity. And so this time I can't have a point. So this would be my final answer, and now I'm completely done. What do you guys think about that? That's not so bad, is it? We know how to FOIL, we know how to plug and chug. It's just a matter of doing it a little bit differently. All right, we have one more topic to go in this section. But before I do that, are there any questions or problems of what I have already done?
good.
All righty, so then let's go ahead and let's do that. So the last thing that we need to talk about is something that is called the implied domain. And I don't want you to get hung up on the word implied. All this means, let me write it out here. All this means is we want to see, notice I'm using quotes here, which numbers could make our function true. That's it. We just want to see which numbers could make our function true. Now, there's a couple things I need to tell you first so that this makes more sense. And then when we dive into the problems, I think it'll tie together. So we have these two rules, and they're super duper important. And you know how sometimes I say you just have to memorize things? These are what you're going to want to memorize. So rule number 1, when it comes to our implied domain, we're going to be given a function. You're going to look at it. Here's what you're looking for. We're going to say if there is a fraction, which we see a lot of. Okay, so if we see a fraction with a variable in the bottom, we don't care about the top at all, only the bottom. We see a variable in the bottom. So for example, maybe we have, 1 plus 2x over 3x. I don't know. This is what I'm talking about. If you see a variable in the bottom, what that means is the bottom cannot equal 0. And we know that because we know that we are not allowed to divide by 0. So the bottom cannot equal 0. That's rule number 1. If you see a fraction and it has a variable in the bottom, we know that the bottom cannot equal 0. That's not a new concept. We've been doing that pretty much since day 1. Now, rule number 2, okay? If there is a square root, there's a square root symbol, okay? The stuff, and I use that word loosely because you never know what it's going to look like, okay, but I'll show you in the problem. The stuff under the radical symbol must be greater than or equal to 0. Whew, barely fit that on there. That looks bad. Must be greater than or equal to 0. Okay, we kind of knew that because when we did 0, when we did square roots way back in the day, at first we weren't allowed to take the square root of a negative number. So that's rule number 2. If there is a square root, the stuff that's under the radical must be greater than or equal to 0. That's it. Those are the rules. So if you have a variable in the bottom, bottom can't be 0. If you have a square root symbol, stuff under the square root must be greater than or equal to 0. That's it. Now, are there any questions on what those two rules say? I'm about to show you what that means, But any problems with what the words say? Do we need another second to write?
I'm good.
Okay. And let me see. Okay. All right. So then what's going to happen is, here's one more super duper important thing. If neither of these two rules apply, so that means if you have something that doesn't have a fraction with a variable in the bottom and there's no square root symbol, then what happens is, then there is no restrictions and the domain is all real numbers. And so what's pretty cool about this is when you're given a function, it's going to be super easy to determine if there's no restrictions. And if you look at it and you can tell right away there's no restrictions, you don't have to do any work. All you have to do is write all reals. So that's pretty neat. So if neither of the two rules that I gave you applies, then you get to say, hey, guess what? All reals done. And no other work needs to be shown. All right, now we are ready to dive into the problems and check for the domain. Any questions on what these rules tell me? Because now it's just a matter of looking for them and doing them.
Would you have an example that we could write beside that little point of what it would look like?
Beside this guy right here?
Yeah.
Sure. So what if we have f of x, and I'm making this up completely, so 3x squared minus 7. I don't know. So what's going to happen is you're going to look at this, and you're going to ask yourself, rule number 1, is there a fraction that has a variable in the bottom? And you say no. And then you say, okay, well, I'm still looking at it. And so rule number 2, is there a square root symbol in this problem at all? No.
Yeah.
And so because of that, this guy's domain without any other work is all real. So here's an example.
Okay.
And all you would have to do is write that, and then you would be done. Okay, better?
Yeah.
All right, now let's take a look at what happens when there is a restriction, because this is a piece of cake. That was easy, no problem. But let's look to see what happens when there are restrictions. So what if I tell you f of x equals the square root of x plus 1, and then on the outside of the square root symbol, I have a minus 7. Well, question number 1, is there a fraction with a variable in the bottom? No. Question number 2, is there a square root symbol? Yes. And so because I see the square root symbol, the stuff, which in this case is just this little piece, the stuff under the square root symbol, which in this case is x plus 1, must be greater than or equal to 0. Do I care about the 7 at all?
No.
Nope. So I don't care about that at all. All I care about is the stuff under here. Well, I know from previous problems that what I'm going to have to do here is solve for x. So I'm going to minus 1 from both sides, and I'm going to say that x must be greater than or equal to negative 1. Now, technically, this is the domain, technically. However, I need to put it on a number line so that I can show you guys what it looks like. And then I want to write it, remember this, way, way back, interval notation.
So why did you ignore the negative 7?
Okay, so what's happening is, according to our definition, when I'm looking for the domain, I'm looking for numbers that could make my inequality true. No matter what number I pick, it's going right here where this x is. Doesn't matter. This little negative 7 will never be impacted by the value of this x, ever. And so because of that, I don't care about him. This number 1 is what's going to be impacted. If I pick 10, this is going to turn into an 11. That 7 is still going to be 7, so it doesn't matter. If I pick negative 20, this is going to turn into negative 19. That 7 will still be 7, so it doesn't matter. Okay, so I only care about the stuff under the radical. Okay, so what's going to happen then, once I have, Sparky saying class is almost over, once I have the fact that x is greater than or equal to negative 1, I'm going to come over here to my number line. I'm going to say, all right, well, I'm going to put it on a number line so I can visualize it. So I know because it's in a double inequality symbol, it's going to be a bracket. And because it says greater than, I'm going to shade to the right. And I know that I'm shading all the way. And so what's happening is any of these numbers in my shaded area, I could pick and I could put them right here with my x, and my whole entire function would be true. Any number that is not in the red, so any number over here in the black, if I picked it and I plugged it into my function, it would be false. And so now I have my domain figured out. I have it drawn on a picture. I need to write it in interval notation. So when we talked about interval notation, we said, well, how far left does this thing go? Well, negative 1 with a bracket. How far right does this thing go? Well, positive infinity with a parenthesis. This is the final, total, and complete answer. This is what you put into Hawks. This is what I want to see on the exam. So from start to finish, let me erase some of this so it's not as messy. But from start to finish, when you look at this problem, what are your thoughts? We ask ourselves a few questions, and we got, the stuff under the radical. We said, oh, okay, we're good. And so we came down here, we solved for it. This picture is not necessary. You do not have to give me a numbered line. I think it helps, but again, this is what your final answer is. So what are your thoughts?
Is y always going to be infinity, positive infinity?
No. Okay, it will not be. In this particular one, if there is a greater than or less than symbol, whichever, there will be an infinity involved. It could have been the other way, right? This could have said x is less than -1. Then, of course, it would have been shaded the opposite direction. But no, this y will not always be a positive infinity. It just happened to be that here.
But I thought, like with rule number 2, all the stuff under the square root is greater than or equal to 0.
Okay, it is. So let me see something. Hold on one second. Let me get rid of some of this junk, okay? Okay, you know what? I see what you're saying. Okay, I'm going to go ahead and say yes to that because you're right. Okay, I've misunderstood you. You're right. So
Okay.
in this type of a problem, let me rephrase that. However, you will see, and I think this is what I meant, the problem that we're about to do, this is going to be an actual number, but the problem is going to be different. So yeah, you're right. I'm sorry. Anytime we have the square root symbol, then yes, it's going to be heading towards positive infinity. That's a safe thing to say. Okay, I apologize. Yep. Okay, so let's take a look at one that has a fraction so that you can at least be exposed to that. So what if we had a problem that said h of x equals 2x over 1 minus 3x, let's say. Now, question number 1, is there a fraction with a variable in the bottom? Yeah.
Yes.
And so we're going to stop right there. Now, do we care about the top at all? No.
No.
And here's why. If we are trying to divide and we have a 0 on the top, that's okay. But if we are trying to divide and we have a 0 on the bottom, that's a big fat no. So I don't care about the top. It could be 0, but I don't care. All I care about is this right here. I know that the bottom, whatever it might look like, in this case it's 1 minus 3x, that cannot equal 0, ever. And so now I'm going to get x by itself. So I will subtract 1, and I will get negative 3x cannot equal -1. And I will divide both sides by -3, and I will get that x cannot equal 1/3. That is my answer. However, remember, I need you to put it, I need us to give our final answer in interval notation. And I also think that putting it on a number line will be beneficial to you, specifically for this reason, or specifically for this problem. So what's happening is, here's my number line, right? All the numbers in the whole wide world. The only number I can't use is 1/3. So let's say, all right, you know what? Here's 1/3. So what this means is, all of these numbers that are out here, good, 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 good. Oh, hey, look, here's 1/3. Not good. Got to skip it. But then I start over here, good, 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 all the way. And so what I'm going to ask you is this. How far to the left am I good, so to speak? How far to the left did I go and that was okay? Pardon me?
Infinity or negative infinity?
Negative infinity. Good. Okay, and then I was good, I was good, I was good. And then I stopped right at 1/3, right? And I jumped over it. I said, you know what, 1/3? Not today. And I said, forget you. And so I jumped over it, and then I started again. I said, okay, good, 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 good. So what's going to happen here is I'm going to have 2 intervals. They are going to be connected with my union symbol. The number 1/3 will have to be in both of them. The reason why is because I'm excluding it. And we learned way, way back, when I use a parenthesis, I'm actually excluding that interval. So I'm saying, you know what, I'm getting really close to 1/3, but I'm skipping over it. And so down here, and I'll put it in a blue box, this is actually my final answer right here. So from negative infinity to 1/3, all of this is good. I skip 1/3 by excluding him, and then I say, oh, well, from 1/3 on is good. So every single number except 1/3. So what are your thoughts on this one? The process is exactly the same. We did the exact same thing. The new part is how we have to jump over this number to 1/3. All right, let's do one more, okay? And it'll be much quicker. Let's do one more just to make sure, and then we'll call it a day, and I'll let you ask your questions. And so what if I have f of x equals 3x plus 4 on the top, and on the bottom I have x plus 6. So question number 1, do we see a fraction that contains a variable on the bottom? Right off the bat, the answer is yes, we do.
Yes.
And we know, that didn't sound very happy. We know that we don't care about the top. We only care about the bottom. So we know that x plus 6, whatever happens, it cannot be 0. So all I have to do is subtract 6, and I'm going to get that x cannot equal -6. And so I'm looking at every number in the whole wide world except -6. And so I'm good over here. I'm good. Skipping over -6. I'm good. So the methodology here is going to be the same. How far left am I good? Well, -infinity. Where do I stop being good? -6. But I'm also going from -6 to positive infinity. And so again, my domain is kind of big, but this is it. Now we're done. What are your thoughts on finding the domain mathematically versus looking at a picture? You only have 2 rules. Any questions? Any problems?
No.
Not bad.
Okay, so overall, what are your thoughts on section 4.1?
Pretty easy.
Okay, anybody else want to jump in?
I feel like this is a lot for just 4.1.
It is, but how bad was that? Was that very bad? Really? I mean, really?
No, not that bad, just a lot.
It's a lot, but again, we knew how to do a lot of it. We know how to solve for y. We know how to rearrange the equation to get y by itself. We know how to plug values in and solve for them and get values back. We have been graphing, so we kind of know how to graph. So overall, I mean, that's it. That's section 4.1. Is there anything else anybody wants to add before we call it a day? Anybody want to chime in before we go? I see 9 of you. I haven't heard from all of you. Anybody else have anything to say?
I have a question.
Okay, go right ahead.
If we're still online by the time our final exam comes, is it still going to be cumulative?
You know what? I don't know, because we've never had to do this before. And so I am waiting to hear from the university, and not just me, of course, everybody, as what we're going to do. I don't know if you guys know this or not, but the president extended the stay-at-home order until at least April the 30th. I think that was yesterday that happened, or the day before. So I can't imagine that Fairmont State's going to allow us back, but that's my personal opinion. I don't know. So if they come out and say, hey guys, we're not going to come back, then Lindsay and I and our little team, we will have to meet in a Zoom meeting like we are, and we will have to decide what to do, because honestly, this is uncharted territory. I don't know what we'll do. Okay. But I will be here for you guys every step of the way. And if it is what it is, then we'll work one-on-one if we have to, but I'll get you guys there. Okay.
Are we gonna look over our tests tomorrow? How are we gonna do that?
So what I tried to do was I went through and tried to write notes on your exam. And I will go later today. In fact, I can do this. I will upload the exam from last semester. The problem is when I give an online test like this, no one took the same test. Everyone's test was different. So I don't have a key. I went through and took the test, and then I went to Grade-Yours and I said, crap, this matches nobody's. I didn't know that. So I don't have one specific key. So I used the one from last semester. And then what can happen is you have your results that you wrote on paper. You can look at the results that you did, and you can look at the key that I uploaded from last semester, and you can say, oh, I missed number 5. It's similar to this number 10. And then you individually can message me. I mean, I'm not sure. If you have any better ideas, please let me know. But for the time being, I think we'll go with that.
When are we gonna get those? The ones that you checked on our papers?
So I went through Hawks and I changed grades, because a lot of you had points that you missed because you were wrong in Hawks, but you were really right. When you uploaded your submission, for the most part, I was able to put notes and write on there. So if you go back to where you actually uploaded your test, unit 3, like test assignment or whatever I called it, and you click like review or look at submission, you're going to see little blue pieces, like little blue dots on your paper. That's where I put notes. If you click on those, you should be able to read it. And then if you have further questions, just reach out to me and let me know.
Okay.
Okay. Go ahead. Lakin, are you okay?
I uploaded mine to you through my email.
Yeah.
How do I get that one back?
Okay, you're not. That's the problem. That's why I was like, oh. So what I'll do is I can go back through. Oh geez, I'll have to go back through and look at that. Let me write that down. I'll have to reach out to you separately and just let you know kind of what happened. That's one of the reasons why I'm kind of like, hey guys, let's really try to get these uploaded correctly, because a couple people had to email them to me and I was unable to make notes on your papers like that. So we have to try to work on that for next time. Okay.
Okay.
All right. Other questions or problems? I'm done with you. If you're good and you want to leave, you're good. We'll come back tomorrow. We'll do section 4.2. If you want to stay and ask me questions, also, you're more than welcome to do that. But that's what I've got for you today. So how do we feel about the Zoom? Do we like this better?
I
Yeah.
like it.
Yeah, it was a little, I think it's a little better. I liked it. I thought it was easier. So that's what we're going to do. If you've looked around the Blackboard, you're going to see that I do have some stuff for 4.2 up already. I'm going to work on that more tonight. And then by end of day tomorrow, you're going to see that the section 4.1/4.2 assignment, it's actually already available. But by the end of day tomorrow, you'll be able to work on it. So you know what to do. Hawks is still going. I checked grades. Everyone should be up to speed. So any further things, let me know.
We don't have anything due tonight.
No.
Okay.
No, nothing's due tonight. So the stuff from yesterday, 4.1, will be due in 2 days. So tomorrow by midnight. So, all right. Anything else, guys? I see someone's chiming in here via chat. Let me see what's going on. Hold on. Okay. Yeah, Danae's saying have a good day and be safe. Yes, you too. Okay, I'm done. If you need me, I'm here. If not, then you're good to go. So anything else before we all sign off?
No, I'm good.
Okay. Then I'll see
Bye.
you guys tomorrow. Have a good day. Let me know what you need.
Okay.
Bye.
All right. Bye, guys.